Section 3.1, Functions and Function Notation. Determining whether a relation represents a function. Now, a relation is a set of ordered pairs. The set consisting of the first components of each ordered pair is called the domain, and the set consisting of the second components of each ordered pair is called the range. Consider the following set of ordered pairs. The first numbers in each pair are the first 5 natural numbers. The second number in each pair is twice that of the first. So we have 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. The domain is 1, 2, 3, 4, 5. Which are the first, or the x coordinates. And the range represents the second coordinate. So it's 2, 4, 6, 8, and then 10. And therefore there is your range. Now note that each value in a domain is also called an input value or an independent variable, and it is often labeled with the lowercase letter x. And each value in the range is also known as an output value or a dependent variable, and it is often labeled with a lowercase y. Now, a function f is a relation that assigns a single element in the range to each element in a domain. In other words, no x values are repeated. For our example that relates the first 5 natural numbers to numbers double their values, this relation is a function because each element in a domain is paired with exactly one element in the range. Now, let's consider the set of ordered pairs that relates the terms even and odd to the first 5 natural numbers. It would appear as following: odd 1, even 2, odd 3, even 3, odd 5. Now notice that each element in a domain, even odd, is not paired with exactly one element in the range. For example, the term odd corresponds to 3 values from the domain, 1, 3, and 5. And the term even corresponds to 2 values from the range, 2, 4. This violates the definition of a function. So this relation is not a function. So figure 1 compares relations that are functions and that are not functions. So here is a relationship as a function. You have an input going to one output. You have an input going to one output. You have an input going to one output, which means that this relationship is a function because each input is associated with a single output. And note that the input Q and R both give outputs for N. The next one, we have an input of P, an output of Q, an input of Q, an output of Y, an input of R, an output of Z. This relation is a function. In this case, each input is associated with a single output. Part C, a relation. This is not a function. You have an input of P going to one output, where you have an input of Q going to 2 outputs, one Y and one Z. So therefore, this is not a function. So this relationship is not a function because the input Q is associated with 2 different outputs.